Hey guys, I bet you thought we weren't gonna have a lesson today because I'm not in class today. But no, we're having a lesson, guys. So yeah, I hope we're happy. All right, let's get right into it. We're doing volumes by cross section. So the main thing that you got to know here, guys, is in order. So make sure to read all this. Read all this, please, because it's all pretty important. And so what they're trying to conclude here is how do you find volume? So I'm going to write a right circular cylinder here, guys. So here's how you find volume. And it's all pretty basic. So if I want the volume of this cylinder here, what would we say? We would say volume equals, and then we would find the area of the base here. And so that base is pi r squared. And so that's just area. And then we add an element of depth. So pi r squared times that third dimension is height. And there it is. That's my volume, correct? So the whole idea, guys, is look, no matter where you cut it, like let's say, pretend this is a cake shaped like a cylinder and I do horizontal slices. No matter where I cut it, if I cut it there, that cross section is a circle. If I cut it here, this cross section is a circle. And of course, I mean, we wouldn't use calculus with this one. This is just right circular cylinder, so you would just do pi r squared times h. So the whole idea here, guys, is that I'm gonna add every single slice. So that's how we're gonna say that volume is gonna be the integral. If I call this A and up there B, A to B of the cross section A of x, and then multiply that by it. Well, right now this is not the x-axis, but if it was the depths, this is your change in x, right? Of course, if I add an element of delta x, that's going to give it depth. So a of x times dx. So there's your area cross section times your dx gives that volume. And if I add up all these slices, this is the volume, guys. So that's how we are going to identify volume. So if you add up an infinite amount of slices of cross sections all the time, that's going to give you or add up to volume of this cylinder. So that's the whole idea. So the whole thing is we need to find a common cross section. Hold on, let me change this to tablet mode. All right, so let's get right into this. And I actually, you know what? I'm not going to want it in tablet mode because I actually did some really cool renderings, drawings. All right, so let's see. A mathematician has a paperweight base so that its base is in the shape of a region between the x-axis and one arc of the curve y equals 2 sine x. All right, so here's my arc. Each cross-section cut perpendicular to the x-axis is a semicircle. Okay, so here is a cross-section and it's coming out of the board, guys. So you can see it right here. It's coming out of the board. See, here's a cross-section and it's coming out of the board. Okay, what do they want? Find the volume of this paperweight. All right, in case you're having a hard time visualizing, guys, I actually did an example of how this looks like. And here it is. Sorry, guys, there was a little hiccup there. All right, so here's my y equals 2 sine x. And then I have a little blue line here. I'm just going from 0 to pi, actually. That's at 0. And in order to animate this, I think I should have it up. Do I have it up already? No, I don't. Okay. Let's see, 2 sections, 0 to pi. So the volume is 2.46740. We're going to calculate that in a little bit. See, solid. All right, so at the first glance, you can't really see it. But look, let me show you. So here's the base. So here, look, let me fix it. See, there's your y equals 2 sine x. So there's your base. And so let me flatten it out. And look, there it is, common cross-section. Each cross-section is a semicircle, guys. And when you put all those common cross-sections together, here's what you get, this image here. So hopefully this visual is making is making you be able to see this problem better. Man, come on, what's wrong with me today? I guess because it's 4:47 a.m. All right, let's get right back to it. I have to pause this again. All right, so here we go. Let's calculate the volume, guys. This one is one where you're gonna need a calculator. You're just gonna need it. So grab a calculator. All right. So here we go. What you're gonna do first is we're gonna calculate the cross section a of x. So the a of x, the area. This is a semicircle. So the semicircle is pi r squared divided by 2. Correct? Well, this is in terms of x, and right now I have an r, so I gotta fix it. So my radius. The radius is the distance from the x-axis to the middle of this. That's my radius. So right now I have access to the diameter. You see that in blue? Guys, do you guys see that in blue? I'm not hearing you guys. No, I'm just kidding. I can't hear you guys. This is a video. It's a YouTube video, guys. Come on, you guys know this. You guys got tricked again. Haha, Chavez 1, you guys 0. Okay, anyways. This in blue is your diameter. And the diameter is the distance from the x-axis to this curve. And that curve is dictated by 2 sine x. So here it is. We're going to say pi, and then I'm going to write 2 sine x divided by 2, because the 2 sine x is the diameter, but when I divide by 2, it becomes the radius. Divided by 2, close it squared. Now, these 2's cancel out, 2 and 2, and you still have this square there. So here's what you have. You have pi over 2, and then the sine x is being squared, so sine squared x. So how do I find my volume? My volume is integral from 0 to pi. Now notice these are all dx's. All those cross sections are dx's. 0 to pi of pi over 2 sine squared x dx. Now this is a product, and the pi over 2 is a constant. So a lot of times we just pull that out, guys. So volume is pi over 2 integral 0 to pi of sine squared x dx. I'm going to type that into my calculator here that I have excuse me, with me. Pi over 2 times math integral 0 to pi of sine squared, open parenthesis, sine x close square by 2x. And I got 2.4674011, which I believe was the exact volume that we had when we had WinPlot open. And that's it, guys. I hope that made sense. So in example 2, all we're doing is we're finding area of cross section. So let's read this. For A through D, find the formula for the area A of x of the cross sections of the solid that are perpendicular to the x-axis. So that's the key. They're perpendicular to the x-axis. The solid lies between the planes perpendicular to the x-axis at x equals 0 and x equals 4. The cross sections perpendicular to the x-axis between these planes run from y equals negative square root of x to y equals square root of x. So we're just finding cross sections because that really is the hardest part, guys. So letter A. The cross sections are circular discs with diameters in the xy plane. Okay, so we're in the xy plane here, and I can see that this is a circle. So they're making it easy now for me because this part of the, let's see, what's positive, xy? This part in red, not counting the diameters here, that in red here is y equals square root of x. And then this in blue is y equals negative square root of x. And it's the same thing as saying that x equals y squared. That would plot it, a parabola opening up in the x direction. All right, so my cross section, A of x. And they're circular discs, so that means they're circles. My radius is this distance here in green. Let's use all the colors. And so let's see, if that's the radius, then it's going to be pi, and then it's going to be the distance from the x-axis to that curve, that's square root of x. Close it and put a square, and there it is, pi r squared. So my cross section comes out to be just pi x, because the square root of x squared is just pi x. So if I wanted to find volume, they're not asking for it, but if I wanted to find volume, I would just go pi integral 0 to 4 of x dx. And of course, this is one that you don't need a calculator for. You can do that one by hand. Okay, the cross sections are squares with the bases in the xy plane. Now, I did do this one already, like to give you guys a visual of how this looks like. But because I'm running short on time, guys, I'll talk about this on Wednesday when I see you guys, because tomorrow you have a seminar exam. So again, the distance from here to here, that's y equals square root of x. But I don't want that distance. I want the total distance. So you can do one of two things. You can either say, well, the distance from, this is symmetric about the x-axis. So you can say the total distance is just twice of this, so 2 square root of x. Or you can say square root of x minus a negative square root of x, and you'll get the same answer, 2 square root of x. So that's how you find that distance. Now, these are squares. So how do I find area of a square? I don't hear you guys. Nah, I'm just kidding, guys. Area of a square is side times side. So 2 square root of x is one of the sides, and you just square that sucker. And that really is how simple it is, guys. So when I square it, let's see, 2 times 2 is 4, and then square root of x times square root of x is x. The hardest part really is algebra, guys. If your algebra is weak, we're going to have a hard time. So please, please, please brush up on your algebra. The cross-section of squares with diagonals in the xy plane. All right, so the diagonals are in the xy plane. So that means this distance here. So let's think about it, guys. The diagonals, so here's my diagonal. It doesn't look like this one. It looks similar to it, but this point here is going to be coming out. This diagonal there is going to be on the base of this parabola, and this point is going to be at the highest point coming out of the board. So that means this distance is 2 square root of x. Now, hopefully you remember that in a square, all these angles are 90 degrees, so that means this is 45. So we have a 45, 45, 90 triangle, and what's important is for us to get this distance. So I'm going to put question mark. We need to get that. So how do we get that? Well, in the 45, 45, 90, 45, 45, 90, we have n square root of 2. So at the moment, 2 square root of x equals n square root of 2. So that's my diagonal. So n square root of 2 equals 2 square root of x. I'm going to divide by square root of 2. So n equals 2 square root of x divided by square root of 2. Let's rationalize it. So we're going to multiply by square root of 2 over square root of 2. I'm going to give you guys a little bit to catch up. Okay. So when I do that, so we get, let's see, 2 square root of x times square root of 2. They're both inside that radical in there or inside the house, so that you keep those together. 2 square root of 2x divided by 2, and those 2's are going to cancel out. So you got the square root of 2x. So remember, it's just algebra. So that's one of the sides. So if that's one of the sides, that means that my area is going to have to be, that's an equal sign. This board is being a little sensitive. Let's see, square root of 2x. Both of those are on the inside. Square it. So my area is just going to be 2x. So if I wanted the volume, I would integrate from 0 to 4 of 2x. And that would be an example of one that you could do without a calculator. All right, the cross sections are equilateral triangles with bases in the xy planes. So imagine equilateral triangles, guys. So let's see how that would look. An equilateral triangle. So this peak would be coming out of the board. That's my height right there. And this distance down here would be the total distance from this vertex to this vertex would be 2 square root of x. All of these are 2 square root of x. Now here is a 60, here's a 30, because I cut it right down the middle to get the height. And so let's see, so then that means the distance from here to here is square root of x. And a 30, 60, 90 triangle, it's n square root of 3 and 2n. So that square root of x is the small leg, and to get the long leg, which is the hypotenuse, which is the height, sorry, it's going to be this square root of x times square root of 3. So I'm going to have square root of 3x. Does that make sense, guys? All I did was took square root of x and multiplied by square root of 3. All right, so here we go. Area. 1/2 base 2 square root of x times height square root of 3x. So my area is, let's see, 2 and halves cancel out. So square root of x times square root of 3x, I'm going to have x square root of 3. I think some books write square root of 3 with an x on the outside, guys, but I'm always a little confused if x is inside or not. So there it is, no confusion there. All right. Here is one from 2008. I think we already did letter A and B together, guys, or we did it recently. But we'll start it again anyways, no big deal. And yeah, let's get this rolling, guys. So from the 2008 exam, so calculator is required. So let's see if we can do this. Let R be the region bounded by the graph y equals sine pi x and y equals x cubed minus 4x, as shown in the figure to the right. So the first thing I would do, guys, I would put this in y1, and I would put this in y2, because you can use a calculator. So let's do that right now. y1 sine pi x, y2 x cubed minus 4x. All right, I have them in my calculator. If you graph these, it's easy to tell which one's the sinusoid. So this one right here is a sine pi x, y equals sine pi x. Don't just write pi x, guys, just write y equals sine pi x. And this one down here is the x cubed minus 4x. All right, find the area of R. So they want this area, and that's easy to find. Which one's on top? The sine pi x is always on top. And then we're just going to subtract x cubed minus 4x. So area equals integral from, that is 0 to 2 of sine pi x minus x cubed minus 4x dx. Now we have to just show it like that, guys, because they didn't tell me one's f and the other is g. So in this case, they're forcing us to write them out. You don't have to do antiderivative because it's a calculator question. So you can just, this is called a setup. So there it is. There's a setup, and just give the answer. So math integral 0 to 2 of, I have it in y1. So alpha trace y1 minus alpha trace y2. Put an x, enter, and I get a perfect number 4, which is interesting. I was not expecting that. All right. So next it says the horizontal line y equals negative 2 split the region R into 2 parts. So here's y equals negative 2. Boom, there it is. Write, but do not evaluate an integral expression for the area of the part R that is below the horizontal line. Okay, so they want this area here now. So I need a comma, I'm just going to say a comma, some y value. I don't care about the y value. So I'm going to put a comma y 1, I guess. And I'm going to put b comma y2. I need the a and the b, guys. So I already have it here in my calculator. So I'm going to fix my window to make it look like this. So let's see, x min, negative 1, x max, that's a 2. So I'm going to go a little bit to the right of that, 2.5. X scale by 1, that's fine. Y min, I'm going to go negative 3.5. Y max, I'm going to go 1.5. And I always like to go a little bit higher, guys, and a little bit lower, and a little bit to the left, and a little bit to the right. Okay, so it's already in my screen. And then on Y3, I'm going to type in this number, negative 2. I'm going to go back to Y equals. Maybe I should have done that earlier. Okay, I need the intersection points. So here we go. Second, calculate intersection. And then it's a red curve, or in mine it comes out red, but you're going to have to just use your arrows or your cursors. So here's what I got. I got A equals 0.5391889 comma negative 2. Oh, I'm a dummy. What is this y1 value? It has to be negative 2. How come you guys didn't tell me? I can't hear you guys. I apologize if I'm being rowdy here. And I need the b value. All right, the b value, let me do it again so I can calculate number 5. And enter, and then scroll to that one. The b value is 1.675139. And there it is, a and b. This is my upper limit, and this is my lower limit. And, oh, let's erase that -2 down there, right? And it says to not evaluate, so I don't have to evaluate, guys. So I'm just going to write integral. And I'm going to put a down here, and then I'm going to put b down there. And you already have it defined. There it is. So perfect. This is looking beautiful. And then I write, what's on top? The 2 curve, the -2. So -2 minus, and then the bottom curve is the x cubed. X cubed minus 4x close dx, and there it is. Beautiful. Beautiful. All right. The region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square. Find the volume. Okay, so here's what's happening, guys. I'm going to go as slow as I can go. I have cross-sections perpendicular to the x-axis. So here's my slice right there. And coming out of this paper, or coming out of the board, is a square. Does that make sense to you guys? And I'm going to add up. You have a whole bunch of different squares. Obviously, the smallest square is as you reach your endpoints because you don't have a square there. See, all these cross sections, you have squares coming out, all of them. So we want the volume. So here we go. It says find the volume of the solid. So volume equals, so first let's find our cross section, a of x. So the top, the top curve is the sine pi x. So I'm going to put giant parenthesis, sine pi x minus the bottom curve is the x cubed minus 4x. So x cubed minus 4x. Notice I made those little parentheses. Close the whole shebang. Put a square on it because area of a square is side squared. So this is giving you one of the sides, and when you square it, that's the area of one of the cross sections. So my volume is going to be integral from 0 to 2 of this expression with a square on it. So giant parenthesis, sine pi x close minus x cubed minus 4x close, put a square on it, dx. Type it in the calculator. There's no need for you to, and use your y1 and y2 in your calculator. So math integral 0 to 2, open parenthesis, alpha trace y1 minus alpha trace y2, close parentheses, put a square on it, dx, and I get 9.9783. And they don't give you units, so there it is. If there was units, you'd say units cubed. All right, let's see if we can do this last one, guys. The region R models the surface of a small pond. At all points in R at a distance x from y-axis, the depth of the water is given by 3 minus x. Find the volume of this. Okay, it's the same thing, but instead of it coming out of the paper, it's going into the paper. So each cross section I do here has a height of 3 minus x. And how do I get area? So it's going to be a rectangle. Because here's my cross section. This is my cross section that has a length, and then the height going in is this. Is this guy right here. So my cross section is going to be, let me read it again just in case. The region R models the surface of a small pond. At all points R, the distance x from the y-axis. The depth of the water is given by h of x equals 3 minus x. From the wild. Okay, yeah, I got it now. So this cross section, length times height, or width times height. Length times width times height, whatever it is. It's something times something gives you area. So this is going to be a rectangle. So here it is. This part in red is that distance there, and then I'm multiplying by the height. So, and I'll explain it more in person, guys. So I know in video it's kind of hard there. So I'm going to do, let's see, where are you? Sine pi x minus x cubed minus 4x, and then that I got to multiply it by h of x to get an area. See, so that's like length times width, or something times height. There it is. There's my my area cross section. So now I'm going to put volume equals integral from 0 to 2 of all this sine pi x minus x cubed minus 4x. And they probably want me to write 3 minus x instead of h of x, although they cannot take penalty if you were to write h of x. I think that would be fine. So let's do that. Math integral 0 to 2 of open parenthesis, alpha trace y1 minus alpha trace y2, close parenthesis, times, let's see, 3 minus x, close x. And I got a volume of 8.36995. And there it is, guys. I hope all this made sense. And let's try to take care of business, guys. Give it your best attempt with the activity. I would really, really appreciate it if you at least made an attempt. Turn it in, and then whatever you don't understand, I'll give you back the activity tomorrow. But please at least make an attempt. So make an attempt, turn it in, and even if it's all wrong, don't worry. I'll give it back to you the next day so we can talk about it if it is all wrong. So yeah, there it is, guys. I hope you guys are happy, and I'll see you guys. If not Tuesday, I'll see you guys Wednesday, God willing, if everything goes as planned. All right, later, guys. Bye.